Okay, section 1.5 is on complex numbers. So you're going to use the imaginary unit I to write a complex number. You're going to add, subtract, and multiply them. And you're going to use conjugates as well to get numbers into standard form. And we'll also find complex solutions to quadratic formulas with complex numbers. Okay, so first of all, the imaginary number I. The quadratic equation x squared plus 1 equals 0 has no real solution because it's shifted up 1 unit. It doesn't touch the x-axis. But if you solve this, you'll get the square root of -1, which is what we call I. So I is just the square root of -1. All right. Now, if you remember, all numbers are complex numbers. When you learned about your number sets, you had complex numbers, then you had like real numbers, and you had imaginary. And then there was different types of real. There was rational and irrational. You remember your numbers that you learned about? So complex numbers are really all numbers. They're actually the real part, which is A, and the imaginary part, which is BI. So A plus BI is standard form. An example would be is if you took this number and wrote it like this, you'd have A plus BI, where A is -5 and B is 3. So that's a complex number. All numbers are complex numbers, and that's really important to remember. Okay? And that's exactly what this says. A and B are real numbers. A plus BI is a complex number. It's written in standard form. If B equals 0, then obviously this real part just drops out, or the imaginary part drops out, and you have a real number. Okay. And if B is not equal 0, then A plus BI is called an imaginary number. And that's all you really need to know. Okay, so here's how to add, subtract complex numbers. You just add the real part and the imaginary part. So this would be A plus C. You just add the real part and put it here. And then you just add the imaginary part and put it here. Same thing with subtraction. You do the same exact thing. So it's pretty easy. Let me show you an example real quick. When you add 4 plus 1 gives you 5, and 7 plus -6 just gives you 1i. So the answer would be 5 plus I, written in standard form, A plus BI. Okay, when you subtract, 1 minus 4 gives you -3, and 2 minus -2 gives you 0. So this is just -3 plus 0i, but you can just write it as -3. You're going to have to simplify a lot of these and write them in an A plus BI form. So here's an example. You want to distribute, you get 3i plus 2 minus 3i minus 2, distribute this, minus 5i. And these cancel in this case. Sorry. These cancel in this case. The 2 and the -2 cancel as well. So you end up with just -5i for that one. For the next one, same thing. Distribute the negative, you get -7 minus I. And then add all the parts together. So this is 4 minus I, and this is 3 plus 2i. So we're going to add the real parts together. 3 plus 4 is 7, minus 7 is 0. So those all canceled. And then we have 2i minus I is I minus I is 0. So this ends up being just 0. You're going to have to multiply complex numbers, like a number times a complex number, which you just distribute, -8 plus 12i. You'll have to multiply two complex numbers together, in which case you FOIL. So it's 2 times 4, which is 8, 2 times 3, which is 6i, -I times 4, which is -4i, and then -I times 3i, which is -3i squared. Now you can simplify this because these two terms add 2i, and this one, I squared is -1, so -1 times -3 is a positive 3. So now you can simplify 3 plus 8 is 11 plus 2i, written in standard form, A plus BI. Now when you multiply a complex number by its conjugate, which is switch the sign in between them, you have 3 times 3, which is 9. The middle terms are always going to cancel. In this case, you'll have -6i and positive 6i, but they cancel. So 2i times -2i is a -4i squared, which I squared is -1. -1 times 4 is 9 plus 4, which is 13. So whenever you multiply a complex number by its conjugate, you actually end up getting a real number, which is going to come in handy when we're trying to simplify some of these into standard form for a complex number. An example then. So this shows up in the web work, and it's a good problem. I'll definitely ask you this on the test because you have to know to multiply the top and the bottom of this by the conjugate in order to get a whole number at the bottom. So you'd have to multiply by 4 plus 2i to both the top and the bottom. You're really multiplying by 1, you can do that. And you have to FOIL all this out. So 2 times 4 in the top is 8. 2 times 2i is 4i. 3i times 4 is 12i. And 3i times 2i is 6i squared. So we can simplify this. I squared is -1, so that'll be -6 plus 8, which is just 2. And then 4i plus 12i, which is 16i in the top. Now in the bottom, you have 4 times 4, which is 16. The middle terms are going to cancel, like we talked about with conjugates. So you have last times last, which is -4i squared. I squared is -1, so it's really 16 plus 4, which is 20. So I'm almost done. Now I can simplify it by doing 2 over 20 plus 16 over 20. 2 over 20 is really 1 over 10. And 4 goes into the top and the bottom of this one to make it 4/5. So that's a plus bi written in standard form for a complex number. All right, so one of the places for application for these complex numbers are when you're solving these polynomials that have, like this parabola has been shifted up 4 units. It obviously doesn't have any real zeros, but it does have imaginary zeros. And to find them, we could solve with algebra by subtracting 4, and you get x squared equals -4. Square root both sides, you get x equals plus or minus. And then this is actually going to be 2i. The square root of 4 is 2, and the square root of -1 is I. So there's our two imaginary solutions. Okay? A little bit harder one would be if we did the quadratic formula. Opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And so we could simplify this. It's 2 plus or minus the square root of 4 times 5 is 20. 20 times 3 is 60. So 4 minus 60, which gives you -56. All divided by 6. And we can simplify that a little bit. 2 plus or minus, we can simplify this a little bit by making it 4 times 14. And now the square root of -1 is I. Square root of 4 is 2. And we still have the square root of 14 there. And then that's all over 6. So, you could do the 6 into both of them and simplify it a little bit more. This would then be 1/3 plus or minus I square root of 14 over 3. So now it's in standard form a plus bi and a minus bi, but there are two solutions. They're both complex numbers for that one. Okay, so these do have some applications for solving polynomials with non-real solutions.